subscribe. Click on the bell. Like, comment, share.
Tomato is good for the skin and eyes. What else is tomato good for? Do you know that an LCD clock can be powered by a tomato battery? At the end of this lesson, students should be able to describe the structure of a simple Voltaic cell and Daniell cell. Explain the production of electricity from a simple Voltaic cell and explain the reactions in a simple Voltaic cell and Daniell cell.
What you have just seen is an LCD clock powered by a tomato battery. A tomato battery and batteries that we normally use are examples of Voltaic cell. What is a Voltaic cell? A Voltaic cell is a device that converts chemical energy to electrical energy. Let's make a simple Voltaic cell. Click on the beaker to fill in the electrolyte. Click and drag a metal to the black wire. Click and drag another metal to the red wire. Is there any reading on the voltmeter? If you get a negative reading, swap the electrodes. Use different metals for the electrodes and repeat the procedure. A simple Voltaic cell is constructed by immersing two different metals into an electrolyte and connecting them by wires. How does a Voltaic cell produce electricity? Click the Start button to find out. Click on the zinc electrode to take a closer look at what happens at the negative terminal. At the negative terminal, zinc atom loses 2 electrons to form zinc ions. The electrons move along the external wires toward the positive terminal. Now, click on the copper electrode. Copper 2 ion from the electrolyte is attracted to the positive terminal, accepts the electrons and form copper deposit at the electrode. Click on the electrolyte. The flow of electrons from the zinc terminal to the copper terminal produces a flow of electricity along the wire. At the same time, ions move freely within the electrolyte. Both the flow of electrons and the free-moving ions produce electricity. Complete the half equations based on what has been observed at the terminals. At the negative terminal, zinc atom loses 2 electrons and forms zinc ion. At the positive terminal, copper 2 ion accepts 2 electrons and form copper atom. Zinc atom loses electrons because zinc is more electropositive than copper. In a Voltaic cell, the more electropositive metal forms the negative terminal. A simple Voltaic cell does not produce a constant electric flow. Do you know why? The simple Voltaic cell examined earlier does not provide a constant electric flow. This is because bubbles of hydrogen gas will be collected at the copper electrode after some time. These bubbles act as an insulator, stopping the electron flow. This phenomenon is known as polarization. Do you know how the hydrogen bubbles are formed? Daniell cell is an example of a Voltaic cell which is not affected by polarization. There are two ways to set up Daniell cell. Examine the Daniell cells. How many electrolytes are there? Name the ions in the electrolyte surrounding the zinc and copper electrode. What is the difference between this setup and that of the simple Voltaic cell? In Daniell cell, two different metals are used as electrodes. Each of the metal is immersed in a solution containing its ions. The two solutions are either connected by a salt bridge or a porous vase. What happens at the terminals? Click on the Start button to check your prediction. Click the terminal to get a closer look. Click the terminal to get a closer look. Click at the salt bridge and see what happens inside a salt bridge. Now, let's recall what you have learned. Drag and drop the answers in the spaces provided. Congratulations! We can also construct Daniell cell by using a porous vase to separate the electrolytes. What happens if the electrolytes are allowed to mix? Type in the symbol of ions that pass through the porous vase.
In this lesson, you have learned that a simple Voltaic cell can be constructed by immersing two different metal strips in an electrolyte and connecting the metals by wires. Daniell cell is an example of Voltaic cell. Electrical energy is generated from chemical reactions in Voltaic cells. In Voltaic cells, the more electropositive metal forms the negative terminal. Metal atoms release electrons at the negative terminal. Metal ion from the solution receives electrons at the positive terminal and gets discharged. In Daniell cell, each metal is immersed in a solution containing its ions. The solutions are connected by a salt bridge or separated by a porous pot. The salt bridge or porous pot separates the solutions and at the same time allows ions to flow through it.
Thanks for watching. Please subscribe and hit the bell icon.